live.
Aloha everyone, my name is Rodrigo Romo. I'm the Director for the Pacific International Space Center for Exploration Systems in Hilo, Hawaii. It's a privilege and an honor to welcome you to the Women in Space Exploration Talk Series. We have a stellar lineup of 7 wonderful women scientists, engineers, and entrepreneurs involved in some of the most fascinating space exploration projects of our times. There is a change in the plan for today, and for this I apologize, but last night we received notice that our scheduled speaker for today will not be able to be with us. Fortunately, there is no shortage of women scientists, and I am excited to say that today's talk will be given by Jessica Dempsey, Deputy Director of the East Asia Observatory, the same observatory that participated in photographing the first black hole, Kovehi, and recently participated in what is becoming one of the most amazing discoveries in astronomy. It has to do with Venus and the possibility of life on another planet. I hope you learn a lot from these talks. Listen closely to their stories and take advantage of the question and answer sessions. Ask them about their work, their challenges, their inspirations, or anything that piques your curiosity. Through these talks, we hope to encourage and inspire the next generation of explorers who will further the great human adventure of discovery in space. Before I go, I want to express a huge mahalo to our partners who have made this program possible. Our friends at Microsoft, for providing technical support and the software facilitating these talks, and the Hawaii Science and Technology Museum, who generously serves as our nonprofit sponsor. Thank you for joining us, and I hope you will enjoy these talks. I will now turn the floor, or the screen I should say, to our host, an astronomer and champion for outreach in the Big Island community, Mimi Fuchs. Mahalo.
Aloha everyone. Thank you so much for such a wonderful welcome, Rodrigo. And welcome again, everyone, to the Women in Space Exploration Talks. My name is Mimi Fuchs. I'm really lucky to be here with you today. For the last 5 years, I've had the good fortune of getting to work in telescope operations for the Mauna Kea observatories. And I love any opportunity to be able to help share a little bit about the science and the exciting results that we learn here from doing science here on the Big Island. I'm really excited to introduce Dr. Jessica Dempsey for our presentation and question and answer today. Dr. Dempsey is the Deputy Director of East Asian Observatory, which operates the James Clerk Maxwell Telescope. Born and raised in Australia, Dr. Dempsey was the first Australian female scientist to work at the geographic South Pole, where she spent 5 summers and a winter over contributing to groundbreaking site testing instrumentation and observations that contributed to our understanding of the cosmic microwave background. She's also a proud member of the Breakthrough Prize winning Event Horizon Telescope team that helped capture the first picture of the black hole. I'll turn it over to Jess. Thank you so much for being with us here today.
Thank you so much for having me, and at very short notice. I am obviously not the speaker you were prepared for, so I'm going to do my utmost in any case to do justice to such an important set of topics as women in space exploration. And I'm hopefully going to introduce you to a couple of people who have really made landmark discoveries in this and how that relates to some of the work we're doing here. So I'm going to try and share my screen. If I can. Right. Okay. Can you guys see that? Fantastic.
Yes.
Right.
All good.
Yes. Oh, fantastic. So I am going to give you a little bit of a history of some really sort of strange things. That collection of words there may not make sense now. I hope they will. So I'm going to talk to you about 3 women, and I'm going to talk to you about space. I'm going to talk to you about Venus. I'm going to talk to you about penguins, and most importantly, the women who have found these things and why they're important for space exploration into the future. So the 3 women I'm going to talk about, well, one of them is me, and I'm going to talk about how you can accidentally become a scientist, which is exactly how my career path sort of started out. I am also then going to talk to you about one of the most remarkable women I have the privilege to know, and a study in perseverance is kind of how I think of as her story. And then the third one is what it takes to do amazing things and a perfect commitment. And so what I'm hoping this week is that we can put a lie to this meme, which is that anytime we look for examples of women in science, let's hope we can expand them beyond just knowing one name in science. And I hope perhaps at the end of this, you'll know a couple more. So who am I? And thank you, Mimi, for that wonderful introduction. I am Jess. My name is Jess Dempsey. I am the Deputy Director of the James Clerk Maxwell Telescope, which I'll tell you a bit about. I have a PhD in astrophysics and astronomy. I'm actually an instrument scientist. And so instrument scientists are kind of the translators between the scientists who know what they want to do out in space but don't know how to do it, and the engineers who know exactly how to build stuff but need to know what they're meant to build. And so while I have a PhD in astrophysics, most of my time has been spent building instrumentation, and that has included in places as far as Antarctica. But I've also been a whole range of other things, including a bartender, a waitress, a bouncer, an actor, a jazz singer, and I've also done comedy production. And would you believe all of these things come in handy in my current job? So one of the things which really enticed me to go into science rather than my plan, which was to be a professional actor, was that I got the offer and opportunity to go down to South Pole Station, Antarctica. And my first season down there, I was 21 and I had never seen snow before, coming from Australia as I did. It was a hell of a shock, but also it was incredibly exciting. I fell in love with it, and I ended up spending 5 summers down there building various instrumentation for my PhD, including a telescope and a robotic telescope at that. And then I got to winter over, and that means spending 12 full months at the South Pole. You're actually more accessible on the space station than you are at the South Pole during the sort of 8 months of winter, because it's too cold to get in or out. And you can see here some of the jobs that I had to do. Most of it was dusting all the snow off of my telescope every day and hauling all of these liquid cryogens up to keep the instrument even colder than the Antarctic temperatures, which can get down regularly in the winter to lower than minus 100 degrees Fahrenheit. I ended up at the JCMT here in Hawaii, mainly because they promised me I would never have to see snow again, and they lied, because Mauna Kea means white mountain, and my very first winter here, I spent shoveling more snow than I did in Antarctica. It's an amazing telescope. It's the largest telescope on Mauna Kea. It's a 15-meter diameter sub-millimeter telescope. What this means is it actually looks at invisible wavelengths of light. Unlike the optical wavelengths you see with our eyes, this actually looks at longer wavelengths, about microwave, or 1 millimeter in length and a little bit less. And looking at the universe in this particular wavelength, you see entirely different things than what you might see in the optical. And that makes it very powerful as a tool. Now, the two you might have heard of recently, firstly, you may be familiar with this image. This is Paveihi. This is the first ever image of a black hole, the M87 supermassive black hole. And this was presented in a result last year. We were very, very proud to be part of a worldwide global network of telescopes. In fact, you need to put telescopes across the entire planet together, including a similar telescope at South Pole, in order to be able to see this image of such a tiny thing, and that all you see there is that superheated gas and dust swirling around that supermassive black hole. The one I'm going to talk to you about today, though, is very recent, and I'm going to talk to you about Venus and this very, very exciting result and why it's important for space exploration. So you see here from the Akatsuki satellite images, the Japanese mission that is currently orbiting around Venus is incredible, beautiful, colored set of clouds and these are hovering above the Venusian surface. These are really, really important because in those central bands there of gas and the clouds just above the surface, we have detected something called phosphine. And that little dip there on the side, which I'll explain a bit more in a bit, is actually this detection of phosphine that I'm talking about. And so that white spectrum was the first detection of it, which was done with our telescope JCMT. And then you see there, that second one in the orange, that was then the confirmation result, which was taken with the huge ALMA array, which is high up in the Chilean Atacama Desert. And there's 64 telescopes there. It's an incredibly powerful tool. So between these two telescopes, this is an absolute certainty that we have detected phosphine in the cloud decks of Venus. So why on earth would we care about it? Venus is kind of Earth's evil twin. What you're seeing here is an infrared image, and that means you can go down deeper than those surface layers of clouds reflect all the optical light, and you're starting to see the surface below. Now, the interesting thing is it really is a very close twin to Earth. It's actually only just slightly smaller than Earth. It's about 150 million miles from here. It has nearly a similar yearly cycle, about 225 days. When you're talking about sending satellite and space missions there, it's actually really, really close. So it's only about a 3-4 month timescale to get a mission to go to Venus, which is important, which I'll tell you about later. Now, while it's a twin, it's not exactly the twin that you'd want to live on. Here's an artist's impression of what the surface looks like and what some of those clouds up in the atmosphere might also look like. The surface temperatures up to 900 degrees Celsius. This is hot enough to melt lead. And the surface pressure is 100 times that of Earth. Wind speeds are horrendous. The atmosphere is mostly carbon dioxide with some other nasties in there. And these cloud decks, which may look pretty when the lightning is lighting them up, but they're actually mainly made of sulfuric acid. So this is not a fun place. And this is the reason that up until now, we've been looking at other places like Mars and the moons around Jupiter, if there was going to ever be life in the rest of our solar system, because looking at this, there's just no way we could think of that the life we know of here on Earth could survive in any of these kinds of conditions. What I'm going to show you here is a movie animation of us diving down into these mid-latitude clouds above Venus. And it's these clouds about 50 kilometers above the surface where we found this gas phosphine. And this is really important, and why we know this, we don't see it at the poles. We just see it in these clouds. These clouds are actually what we call temperate. They're actually at about 30 degrees Celsius, about 86 degrees Fahrenheit. So these are actually fairly reasonable temperatures compared to the surface. And we've found these phosphine molecules sitting there. Now, I want to tell you a little bit about phosphine. What is phosphine? It's a very rare, unstable, volatile, horribly stinky gas. Why on earth would we want to find this? Well, here on Earth, we only find these things being produced by life. We find it in decaying detritus, in swamps. We find it in the guts of animals, including our own. And would you believe the biggest producer of this in a land mammal is actually penguins? What you see there is actually a Adelie penguin colony on the Ross Island, just off of the Antarctic coast. And the reason I show you this is my first summer that I went down to Antarctica, my most exciting thing that I wanted to do was find penguins. And I did. And this was actually the colony that I got to go and visit. And I'll be honest, they are as cute as they look. They are really adorable, but I have never smelled anything worse in my entire life. These colonies are absolutely horrendous. It burns the inside of your nostrils and the back of your throat. And I haven't been able to get the smell out of my mind for nearly 2 decades. What I did not know at the time is this thing I was smelling is phosphine. Phosphine is actually being produced in the guano there, and that is the stink that is produced by penguins. Also importantly, it's a waste product of anaerobic bacteria in our upper atmosphere. So we see bacteria pulled up into the clouds above our Earth, and they output phosphine. It's actually bug farts, to put too fine a point on it. This is why we're excited about phosphine in the clouds above Venus. We also think that because phosphine is so rare, and because we only know at the moment it's produced by life, it has been touted as something we would go and look for on other planets as a hint that we might see life there. But it shouldn't be on Venus. And so when we saw this detection, what you're seeing here is an absorption spectrum. So the actual phosphine is being backlit by radiation below it in the clouds, and some of the phosphine grabs some of that radiation and absorbs it, and that's that dip you see there. So when our scientists found this, they said, okay, we've got to figure out what this is. And they went and they modeled all these options. Volcanoes, nope, can't do it. Meteorites, also doesn't work. Solar wind processes, nope, we just couldn't find any non-life process that could produce the amounts of phosphine that we see. So we are not saying that we have found life, and I'll be very, very clear on that. All we can do right now is say, well, we can't rule it out. There has to be some process that we yet don't know of that is producing this phosphine. And yes, it could be some exotic chemistry that we've never thought of before. But there is the potential that there could be bacteria up in these clouds, somehow protected from the sulfuric acid around it, that is similar here to the ones here on Earth. So this is the team, and here's where I want to segue into my hero here. Some of these people, these are all our local Hawaii staff who are on the paper, including Elisa Lee, you can see there in the left middle corner. She was actually a Hilo student who was working as an operator for us, and she actually collected the data for this. This is the person I want to highlight. This is Professor Jane GREAVES. She's a professor at Cardiff University in the United Kingdom now. She actually started out her postdoctoral work here at the James Clerk Maxwell Telescope in the late 80s and 90s. She actually helped build a couple of the most important instruments for us, including the one that collected this particular result. And Jane is one of the most persistent people I know. She wanted to do this attempt of detection of phosphine. Now, this, guys, is nuts. And it was so nuts that she got turned away from every single telescope on the planet that could do this observation, which are very few. There's actually only 5. Despite this, Jane requested time over 3 years, 26 different times to get these measurements. And I have to admit, even our time allocation committee at JCMT said, no, this is crazy. They turned her down. So she gives me a call, and sometimes we get an allowance as an executive of an observatory to give a little bit of time to crazy projects. Jane's one of our family, and she said, I only need 5 hours of time. I just want to try this. Even Jane did not expect to see this result. What she was hoping to do was get what we call an upper limit, where she's like, okay, we know that there would have to be less phosphine than this in the atmosphere because we didn't see anything. So she was as shocked as anyone when we actually got this result. But it is a really good example of how sometimes you just have to keep going and be committed to knowing that this is important and you keep fighting for it. And this, of course, was the result. We had an amazing run of this on September 14th. So just 3 weeks ago. Here's the New York Times title for it, but they were, of course, all around the world. We actually were the highest Twitter handle, Venus News. But this is the number that I think really means, Jane and her persistence paid off. This was just from our JCMT tagged media around the world. And the readership was over 15 billion people. That's twice the population of the planet. How does that work? Well, it means that one person clicked on more than one link or one particular bit of news item, or clicked on it more than once. But to give you an idea, we're normally happy when we have a science result if we get, we're thrilled with 10,000. So 15 billion we do think is possibly some kind of record. The other amazing and special part of this is Dr. Larry Kimura, who is what he's called the grandfather of Hawaiian language revitalization. He actually helped gift us the name of Pavehi for that black hole image, has given us a new word to describe this result, and it is maka'ola. Maka is a basic word for eye in Hawaiian, but it has many other meanings: visible, seen, alert. Also means the very first. And in the Hawaiian creation chant, makali'i means tiny eyes or dots, or the point of a beginning. And ola means life. So maka'ola, the possible detection of life, has been a word given to us out of this, which we're really very happy with. So, to space. This was one of the best memes that I was pretty happy with that came out of our result a couple of weeks ago, and I love it because it really tells us a little bit about maybe we have been looking for life in the wrong direction. And that includes a lot of these space missions. We've been focusing on Mars and the moons of Jupiter, for example. Maybe now we need to turn around the other way. What you see here is one of the very first successful landings of a probe onto the Venusian surface. In fact, there's been 42 missions to Venus since 1961. And this is one of the Russian Venera 13s. What it managed to do before that poor little rover there, lander, melted into a puddle of goo because of the temperatures and of the sulfuric acid rain, it did manage to send some of these pictures of the surface back to us. And so we know that it can be done. We know that we have to sacrifice some landers to do it. One of the other cool things was Pioneer 13, one of the NASA projects in 1978, actually went down through the surface and sent back detections of what molecules it was finding, and it found phosphorus. Now, this didn't tell us what kind of phosphorus there was, but it's possible that it actually detected this phosphine all the way back in 1978, and we just didn't know about it till now. There are a range of discussions we're going on to about now with Rocket Labs. They're very excited to talk with us about sending a probe, perhaps as soon as 2 to 3 years. There's about 20 other missions around the world which are currently in proposal and design phases. How would we go there and what would we do? Because here's the exciting thing about potentially finding life on Venus. Unlike an exoplanet millions of light years away, we could actually go and get this, detect it, and bring this back within the next decade or two. So we are able to actually go there and confirm this, unlike any of these other places where we might be looking for life. And you see a couple of artist impressions here of some of these ways in which we would take probes down into these clouds and then lift them back up and out and either bring them all the way back home, or in space, in orbit, safely away from the sulfuric acid, we can then analyze it and send those results back. So we're opening up an entirely new space race going back towards Venus because of this result, and that's really exciting. Lastly, I want to talk to you here about another amazing woman. And so what you see here was the entire cohort of women who were about to start their winter over with me at South Pole. And so in the middle there was Christina, and Christina was actually working with us out in the science crew. She was actually our cryogenics engineer. And so you may recognize her because she then went on to be successfully in, this was the cohort of astronauts that she ran through a studentship with. And of course, she then went up into space and is now still the record holder for the longest time a woman has spent in space. And she is an incredible role model and friend of mine. And it's just so interesting to me because when we start talking about women in space exploration, this is going to be the generation where we really start to move the needle on representation of women in all of these fields. And Christina is basically one of the leading lights of this, and it's really important to see how she got to her current source, her current occupation. She went and ticked all the boxes, including that year at South Pole, to get that mental attitude and toughness and knowing what it takes to then go and do what she's done. And so that's why I think it is a new era now for space exploration for women. So of that Venus author team, half of them were women. And that is extremely unusual in astronomy, unfortunately still. But it really, I think, to me, is a sign of things to come. In the winter, we had, Christina and I were 2/3. We made up a female science team, which was about 2/3 women. Again, really unusual because down there the ratio is normally about 10% women. But now, of course, we're talking about new missions to take people back to the moon, going to Mars, and all of these areas. And this is what you see here is the cohort of current NASA female astronomers, potentially at least one of whom hopefully will be setting foot on the moon very, very soon. And the options start to be limitless because we need to colonize all of these areas of space exploration and science. And hopefully this gives you some inspiration for some of the options that you might be able to take. And that's it from me.
Jess, thank you so much. I realize my video, maybe you guys can see me. Dr. Dempsey, Jess, thank you so much for such a lovely presentation. Folks, for those of you who are just joining us, I know we had people trickling in the entire time. Today we are here with Dr. Jessica Dempsey, Deputy Director of EA Observatory, which operates the James Clerk Maxwell Telescope. She just gave us this awesome presentation where we learned a little bit about herself and what went into these very exciting Venus observations. So now we're going to transition into the next portion of our presentation, which is a question and answer. Any burning questions about what it's like working in astronomy or what the next steps are in terms of looking for life on Venus or elsewhere in our solar system? This is the time to ask. So feel free to put your questions in the chat window, send them off, and then we're going to start responding to some of them. Now, remember, if you're a young woman who's interested in space exploration, we really want to make sure you're heard. So in your question, we would appreciate if you just add the hashtag WiSE before sending it along. And I'm going to go ahead and get started and ask the first question, which has to do with these Venus results. Now, it was so exciting that the world just found out about this potential of microbial life in Venus this past September. But what happens when we first find a very exciting observation? Does it immediately turn into a journal article? Did we have to do follow-up observations? If you would maybe just clue us a little bit into how astronomers handle getting really exciting news like this and what the follow-up steps are like.
That's a really, really good question. And in fact, getting this particular result out of the data we just took 5 hours of time looking at Venus with this instrument called RXA, which is a really boring name. Astronomers shouldn't be allowed to name things. But it was also the instrument that collected the light for our black hole image. So it's a very special instrument. But it isn't exactly a camera. You don't take a snapshot and then you go, hey, got this. In fact, getting that little dippy spectrum out for Jane and the team here at the JCMT, which we have some experts in this stuff, it took them about 10 months to go back to that data because Venus is very bright, actually, when we look at it. And the light from Venus bounces all over the telescope, and we had to get rid of all of that extra signal. And then we had to be really certain that that dip we were seeing there was real. So from the time of the observations to the publication was actually, we took that in 2017, so it was very nearly 3 years worth of time, about 25 experts around the world that went finally into that paper. And when Jane sent me the paper draft, which was in December last year, she didn't warn me that she'd found it. And she just sent me it with unasked. And I sat there and I looked at that spectrum and I stared at it for like half an hour. Absolutely gobsmacked. And she just didn't warn me at all. I had to call her up and say, don't do that to me. Okay, is this what I think it is? And that was really, and then of course I had to go Google phosphine because it's not exactly my area of expertise. I just build stuff. So I've learned a lot myself in just the last 6-7 months.
Thank you, Jessica, for sharing that. It looks like we do have a bunch of questions that have come into the live event Q&A. We'll start with the first one. It says, do you have advice for other women who are also interested in doing science at the South Pole? In parentheses, also would love to hear more about how you found that opportunity.
Awesome. Yes, we need more women going down to Antarctica. Trust me on this. So anything I can do to give you advice on this, I'm happy to give it to you. So the South Pole Station is actually an American base. It's run by the United States Antarctic Program and the National Science Foundation. So whenever you go onto the United States Antarctic Program website, they usually recruit around the middle of the year. And the first thing I'll tell you is you don't necessarily need to be in science. They take people down there to be utilities technicians, to move bulldozers, to cook. There's a range of things. If you want to just try it out first, there's a whole set of options. And in fact, they always look for women to run all of the big equipment, including the huge bulldozers, because would you believe the women break things less and they're much more careful on the controls. And so most of the women they select are running all of the big equipment down there. So there's a lot of different options. And I do recommend you go and start with the summer, which is only a few months. And then you figure out if you like it or not before you go the whole hog into a year down there. Now, I am Australian, so normally I wouldn't have had that opportunity, but because we were collaborating on science, which was to build these instruments to figure out how that they wouldn't freeze and die in those terrible conditions, and that's why I ended up down there on a collaboration, and I fell in love with it and just kept annoying people until they gave me a job. And that's why when I finished my PhD, I'd nagged the guys at Berkeley who were building this CMB, Cosmic Microwave Background Telescope. I said, come on, guys, just let me winter for you. And finally, they did let me do that. And that's how I ended up wintering over down there. That was the first half of the question, I think. I remember the second half, sorry.
You'd like me to repeat the second half?
Yes, please, sorry.
Okay, sure. It says, also would love to hear more about how you found that opportunity.
Right. Okay, maybe you did get that into that second part there. Okay, hope that answers the question a bit.
Awesome. I have another question for you, Jess, if you're ready.
Yep.
So this one has to go into the actual scientific discovery of finding phosphine. And it's a pretty simple question. How did you feel?
I just couldn't get my head around the possibility of life on Venus because I was really cynical, and I still am. I am extremely cynical that we have found life on Venus. We don't know how life of any kind here on Earth could survive in those sorts of circumstances. But the reason I got so excited is because if you've heard the word serendipity, there's not a lot of serendipity left in science anymore. It's all very, very big money. It's very, very hard to get time because it costs so much to build space missions and these telescopes. So it's very rare nowadays that you can just give something a go. And so when Jane did that and we gave her the opportunity to just try something crazy and you find something like this, that's the excitement for me, is we've opened up a whole, hopefully, new area of study. Now, whether that means we find life or not, it still shows that you need to have that accidental, discovery space left for people to try insane things like this.
I have some more questions about Venus for you, Jess. The first one is, What is it again? What is the wavelength of the phosphine absorption line? And maybe you could use that as an opportunity to just chat just for a second about submillimeter astronomy, because that's pretty unfamiliar to most folks tuning in.
So phosphine is this funky molecule that has phosphine in the center and then 3 hydrogen molecules on the outside of it. And it's very volatile. What we mean by that is it breaks down very, very easily. So it's not like some gases, which once they're output from a supernova, they hang around forever. It will break down into other things very, very quickly. The actual line, the actual wavelength we're looking at is just over 1 millimeter in wavelength. Now, phosphine, like most molecules, puts out a bunch of different noise of all sorts of different wavelengths. But the reason we can only see this one from the ground is that in the millimeter wavelengths, more of this light can come down onto the surface of the Earth, and we can collect it here, and it's the strongest line. There are other ones in the infrared, but guess what? It gets absorbed into our atmosphere first. We don't get to see them or see them as easily. So this is where submillimeter and millimeter, the universe looks entirely different, because the processes that are outputting this don't get down here onto the planet at all of these other wavelengths. So we're seeing the invisible universe. And it could only have been done in the submillimeter to detect this line. Now, this is the other reason, though, we go to space. So if we want to follow this up, we need to go to a space-based telescope to be able to detect these lines. And so, for example, the upcoming JWST mission is definitely going to be one where we'll be like, hey, guys, do you want to just point that over there, Venus, just for a second? Because, you know, in the infrared, that will be the slam dunk that we need to be really confident that we found this.
Awesome. We have some great questions coming in. The first one, I'm going to toss it in an easy way, which is how bad was that smell when you went to Antarctica with these penguins with the phosphine?
I mean, it smelled like death, noxious death. It was really acrid, horrible smell in that, you know, that kind of, if you ever accidentally smelled acid or something like that. Or, you know, and when we joke about saying it's bug farts, like it kind of has that kind of putrescent smell as well. And I was really upset because I was so looking forward to seeing these penguins, and they just looked so cute from a distance. But I will warn you, if any of you do get to go and have a chance to see these very, very adorable critters, I would maybe, you know, mask up or at least keep your distance from it. But it's a smell that I will never, ever forget.
The funny things we learn. I had no idea that penguins were one of the largest sources of phosphine. Very interesting, though very smelly. All right, we're going to turn it over to talk a little bit more about your career path, and we're going to be hearing from a few folks who are also young women interested in aerospace careers. So the first one is asking about your engineering experience. Can you tell us a little bit more about your experience and share some details on what you're building or something that you've enjoyed building?
Sure. To give you, I'll tell you about one of the very first things I built, actually, because it was actually my PhD project, was to build a small telescope, optical telescope in Antarctica. And I came with an astrophysics background. And so I had to learn all of my engineering on the job. And in fact, you know, I learned all of my understanding. You know, I had to read CAD diagrams. I had to learn how to do drawing programs. All of that happened during my PhD because I had to build a telescope that worked over about a 200-degree temperature range. And that is really, really difficult. And I had to run it on only 7 watts of power. So that was the engineering problem. And so it took me 3.5 years to get that thing and that guy working. It used to break about middle of every winter. It was sinking into the snow. So I had to write this crazy program of tracking on the sky that involved the sinking onto the one side of it. I also will admit, my first summer down there when I went to install the telescope, I had never been in snow conditions before or even below freezing conditions. I was up on the 10-meter tower, and it's if you've ever come across a 3-handed job, which is where, you know, you don't have a second person. Well, one of the things I needed to do was put a brass fitting to connect some fiber optics to the telescope. And I would use my teeth to tighten on there, and I wasn't even thinking, and I did it, and I fed my tongue to the telescope. And it's about minus 40 degrees. I'm stuck up a tower. I'm kneeling down with my tongue frozen to a brass fitting, and no one's around. And you can only do about 10 minutes without moving at these temperatures. So I had a really quick decision to make. And so I just ripped. And so I did contribute some DNA to my telescope. I didn't do that again, ever. But that was the first engineering mistake I would have to say that I made in that particular process. So I learned my engineering on the job, and now what I do, I trust my engineers. And so it's my now job just to understand enough from my engineers to be able to make that communication and translation to do those two things.
Wow, that is awesome and slightly terrifying. I've always wanted to go to Antarctica, but that seems one of the more harrowing experiences you can find yourself in.
Don't do that. Don't do what I did.
And so actually we have someone who wants to know, can anyone go to Antarctica? Do you have to be a scientist to go to Antarctica?
You do not need to be a scientist to go to Antarctica. We need all sorts of jobs to go down there. And it may be truck driving, you may be hauling literal Jet A1 rocket fuel to the aircraft down there. They take technicians, they take mechanics, they take cooks. There is just general utility work. So when you go onto the list of these jobs down there, really what they're looking for is people who are willing to have an adventure, people who are willing to go try something new, and be aware that it's actually going to be a really challenging environment. And frankly, the most important quality you can have is to get along well with people. Because you're down there, we used to joke that it was like Big Brother, but you can't vote anyone off. And you have to be with that certain cohort of people for a very long time. And so the most important thing you need to be able to do is to be able to negotiate, deal well, have interpersonal skills. And that's actually one of the things they look for when they're looking for people to go down to these jobs, is a willingness to get along with people, try anything, and be game for an adventure.
Wow, that's so cool to hear about the different opportunities or the different skill sets they're looking for if you're going to work at the South Pole. We have another question that hits on that a little bit more in detail, but instead is looking towards astronomy. So we have a question that was asked by one of our young scientists, or someone interested in becoming a scientist, who asked if it's necessary to have a PhD in astronomy in order to work in the field of space science. Would you mind just sharing a few words on that?
Absolutely. First answer is no. You do not need a PhD in astronomy and astrophysics to make headway into a field like astronomy and space science in particular. And there are still academic areas that I would say in astronomy, which sort of to jump up those few levels, a PhD in astronomy is a required field. You know what? That's actually a really small subset of the astronomy and STEM field opportunities now in space, especially. And so you can go into a whole host of different ways to study this. And Mimi's doing one, right? Going for a master's, in systems engineering. Things are getting so complex now, not just in space, but on the ground. We need engineers who are just able to track all of the different projects and technical and aspects of a particular project and know how they all fit together. Then you can go into electrical engineering. We need mechanical engineering. We need people who design optics. And we need software is the other huge one, and computer science. So there are a whole host of different ways that you can get into these fields and space exploration and astronomy. And I will say, the people who really make our observatory work are the people who operate the telescope, who run and design all of the software that we need to collect the data, who write the data on the other end and make sure it works. The scientists are actually at the end of that very long list of people who you absolutely need to get that done. And none of the jobs that I did just mention need a PhD in astronomy.
Well said. There's so many.
Mimi, you're muted right now.
I'm so loud in person, I assume you guys can just hear me through my computer at all times. Thank you for sharing that, Jess. I think it's really wonderful to remember that it really takes a village to take care of a telescope, to do astronomy, to do space science. And we do have a lot of questions actually wanting to know more about your particular career path. So another question we have for you is, did you like astronomy and science as a kid? And you know, a lot of people are afraid of going into science careers because they believe it's too hard and there's too much math. So what was your experience like, and what motivated you to go into this career?
I was exactly the same. I loved physics. I loved astronomy. I wanted to do that. But I had imbibed that thing that a lot of, especially girls, do. I thought I was bad at math. Right? And I was like, oh, math, astronomy, engineering, they're way too hard because, you know, that involves math and I don't want to do it. And it took me years to unpick that out of my brain. I'll be really, really frank with you. And what was interesting was I actually failed math in my first year of university. I had to go and do summer school again. That wasn't necessarily an aptitude thing so much as I should have attended a few more classes. But I did learn my lesson. I went back to it. And what I realized is math is a tool. And for me personally, it started to make sense in physics when I started to build things, because I needed the math to build things. And now I could actually see the results of the mathematics that went into this. And suddenly mathematics started to make sense. And I don't need to learn everything by heart, but as you start reusing and using those tools again and again, they become familiar to you. So never ever let anyone tell you you're bad at math, that women are bad at science. In fact, I think we have a better aptitude and practicality sense on a lot of these things. And yeah, there is math involved in physics, astronomy, engineering, but they're tools to be used. And once you get familiar with any kind of tool, right, whether it's a pen or a hammer, then the fear starts to go away from that. And so I cannot say enough that don't be afraid of math.
Hear, hear. Thank you for sharing that, Jess. I think something that's really wonderful about this talk series is it gives us an opportunity to talk to folks like yourself who've done such exciting things in science and shown us that there's a lot of ways to do it. So just a little bit of a pitch to keep tuning in with us this week as we learn about more ways that folks have had really interesting careers working in space exploration. Changing topics a little bit, you know, the COVID pandemic has really upended our lives in 2020. And we have one of our participants who's interested in learning about how the pandemic has made work in astronomy. Has it made it more difficult?
Really good question. I mean, it's made everything a bit more difficult, hasn't it? But it's certainly here. One of the things which is interesting about a lot of telescopes around the world these days is they're going to what we call remote operation. So you've seen all of the cartoons with someone staring through an eyepiece at the sky, and we don't do that anymore. I mean, now we have these massive cameras and telescope instruments on the back end, and we're looking at, even when we're up at the telescope, we're usually looking at a whole, and Mimi knows as well, a whole range of different computer monitors and screens. But up until last year, our telescope, we would actually be up at the telescope, one of our operators, and we would have a scientist who'd come in from somewhere around the world to help to take the observations. And so last year in November, we finally went to fully remote operation. And that meant we no longer have anyone up at the telescope. They actually work and run the telescope from down here in Hilo, which is about an hour and a half drive from the telescope up on the top of Mauna Kea. And this ended up saving us when we got into the pandemic era, when we couldn't have been bringing in scientists from around the world, where it would have been really challenging because we have a rule for safety that 2 people have to be in the telescope at any one time in case one of them gets ill, for example. So we would have had to shut down entirely in our current old operation mode. But with remote operation, it meant that all we needed was our one operator in the building by themselves running the telescope remotely. And that meant that we actually, after we had our first sort of shutdown here in Hawaii, as we, in the first, blush of the pandemic, we've actually been able to kind of seamlessly operate despite the pandemic, and everyone else, like me, as you can see, is working from home. We've really found that we can kind of run a telescope with maybe 20, 25 of our people out of 35 sitting in their kitchens, which is kind of a surprise, but a good one. So, you live and learn how to adapt to all of these things as you go along.
It's amazing to see how many industries, I mean, the observatories included, have been able to adapt in these really crazy and unsettling times with regards to the pandemic. So folks, we have about 10 more minutes to ask questions. So this is the time. Send along your last minute questions. It's okay if you don't have them because we still have a wealth to choose from. So Jess, do you mind if I ask you a few more phosphine questions?
You can try. I'll do my best.
Awesome. This one's actually a little bit further, a step back from the JCMT and ALMA observations. First is, do you think it would be possible for us to potentially get these samples from Venus that would allow us to learn more about the potential for microbial life?
Yes. And that's really, I mean, we talk about engineering challenges, right? So what we would need to actually be sure of what we've found in these cloud decks is a mass spectrometer. So this is an instrument which will collect a gas sample or a liquid sample, and it will break it up into its component parts, kind of like when you're looking at, you know, a rainbow which splits all of the light there. And all of those different things kind of have signatures. A mass spectrometer would tell us straight away whether or not we had microbial life, for example. It would also tell us the entire makeup of the chemistry that is in those clouds. The problem is, mass spectrometers are nowadays huge. Right? They're very, very big instruments. There's no way, and very delicate, that you could strap one onto these tiny little probes, like some of the ones we're talking about, to drop into these clouds. So how do we make these things smaller? Small enough to maybe put on these CubeSats that we could send out with rocket labs. And in fact, we're talking to rocket labs right now about this very thing. It's like, what could we make small enough to get into one of these CubeSats and send off as quickly as possible that would actually be useful? And so that is definitely on the cards. And whether or not we grabbed it and brought it all the way back here, or whether we did it in some sort of orbit around Venus is a question. But I do think that within a decade, we will have samples from Venus that we have actually, maybe 20 years, we will bring back here to Earth and be able to analyze in real time.
That is just so exciting to consider. If we can't wait that long, are there other telescopes that'll help us? Specifically with a question, is the James Webb Space Telescope going to help us do follow-up observations?
I very much hope so. JWST is perfect for this in the infrared light range, which JWST is designed to do, kind of Hubble, but again, going into those invisible wavelengths where we haven't looked quite as hard before, and you absolutely need to be in space to see these particular lines. So JWST could turn around onto Venus, look at some of these other output lines from phosphine. We start to get sort of its fingerprint. We'll know far more about its temperature, about abundances, how much there is there and where it is. And that will be a really, really important result. We're also talking with a couple of the existing current satellite missions to possibly train their eyes back on Venus and see what they can see there. So we have some options we're really excited about.
Very exciting. As someone who's a little impatient, that gives me hope that I'm not going to have to wait another 20 years for an exciting result. Okay, we have a few more questions before we wrap up. I'm going to ask you some biology questions. Where else can we find phosphine? Why do we find so much of it in penguins? Do we find it in humans?
Yes, we do find it in humans in tiny, tiny amounts. In our gut, actually, but it breaks down very, very quickly. The question on penguins is a really good one, and as far as we understand, we do not know. Phosphine is really understudied. In fact, when we talk about it being emitted from microbes in clouds above the Earth, we still don't know where those microbes come from, let alone why they output this amount of phosphine. We just know that they do. So there's a huge range of this field, which is really, really understudied, and this is the other, if you're impatient, these are the other areas we're now sort of shaking our biologists and our biochemists to say, hey, you need to go check out those penguins and tell us how you're getting phosphine out of that. Because the more we understand about these microbes, about why penguins produce so much phosphine, maybe we start to understand the ranges of life on other planets that could be producing something like this. Because right now, it's a really, really misunderstood or not understood phenomena. We certainly don't know how life of any kind could survive in these sorts of atmospheres. But if it is, can you imagine how much wider in the range of exoplanets, for example, that we can look at? Because now we know life can be found in all sorts of crazy places.
Yeah, it really speaks to this multi and interdisciplinary nature of looking for life. We need biologists, we need planetary scientists, we need, astronomers, instrument specialists to really help us and assist us in this really exciting search. So this one has to do with your friendship with other really incredible women in science. So do you still keep in touch with Christina, and did you know she wanted to be an astronaut when you were working together at the South Pole?
Yes, I don't keep in touch with her as much these days because she's a very busy lady. In fact, I got to chat with her 2 days before her launch date. That was the last time, and I managed to talk. I have never been more terrified watching a launch in my life because it was the first time I had someone I cared about on on the shuttle. It was really heart-pounding stuff. But she did know when she came down to do her winter with me, she had already put, her plan in place. That's why I said determination is her sort of metric, because she had gone and said, okay, what do I need to do to become an astronaut? And she'd gone through the list. She's like, okay, I am an engineer, which means I'm going to need the background in all of these other things. I'm going to need these technical skills. I'm going to need to have gone to remote places. And she just went and ticked every single box. And she did 2 winters. She did one at South Pole. She did one at Palmer Station, which is on the Antarctic Peninsula. She then went out and ran a NOAA weather station in Samoa for 2 years. She went and got a pilot's license. She just went and got all of these things in a row. And so that was why 5 years after she and I wintered together. And you want to know the difference of not having a PhD. I had a PhD. She did not. She still does not. She's the one who's gone into space. So it is simply about figuring out what those things were she needed to do. And she just did them all. And I was never in doubt for 1 second, knowing Christina, that she was going to become a successful astronaut. Because that clear-headedness and that determination to just do all the things that needed to be done, there was never any doubt in my mind.
So cool. Okay, I have 2 more questions for you. The first one is from one of our younger participants. It looks like, do you have to take a test to work in astronomy?
Do you have to take a test? You have to take a few. Yes. I would say, in the studying that you have to do, you're going to come across some tests and some exams 1 or 2 times going through that kind of thing. But as we've talked about, there are plenty of different directions to go in to come up and do that sort of thing. And our technicians, for example, that work at our telescopes, they have come up through a very different route than going through an astronomy and physics degree. And so there's tests, but they might be more practical. And it might be more about building something or understanding how circuits work than it may be about knowing about astronomy and science. So, yeah, there's going to be a few tests on your path, but I wouldn't be too afraid of it.
And that leads us to our final question of the day. And it's, what has been your biggest challenge you faced, and what advice would you have for future scientists?
Okay, biggest challenge. I actually, I was going to winter over in a couple of years before my first one. And in fact, I put my PhD on hold, so determined to winter over at South Pole. And I actually got fired from that job. It was a very shocking thing. It didn't end up being my fault. There was a whole bunch of confusion going on into it. But at the time, I got sent home. And I had my whole life planned out. And I had to come back to Australia I put my life on hold. I went and worked in a bar. That's when I became a comedy producer. I sang for my supper. And I had to sort of take about 6 months to get back into my PhD program and try and, get my life back on track. And it was quite a struggle and a challenge for me to have done that. And it's really been really important in my life because I had to build from nothing. And I built a foundation, and everything that I put on top of that, I built. And that is what stood me in good stead going into what I've done now, and why my commitment now and my priority is making sure other girls and women get the opportunities and are empowered and feel like they can be empowered to go into these types of things. Because I don't want you guys to have to deal with all of the stuff. And we don't need to do that. And so that's why my fight is here. And it's informed on some of the times that I've fallen over and had all of these big challenges in my life. Because I want to make it easier for others to come up and do this. And we need more of you. We need more of you to come on our side.
1,000%. Jess, Thank you so much. We've come to an end of today's presentation. A big thank you to Dr. Jessica Dempsey, who came in and spoke with us today about what it's like working as an astronomer on Mauna Kea and some of the exciting discoveries we've had related to black holes and the most recent potential of microbial life here on Venus. It was really wonderful to hear your presentation and also get some of your wisdom and insight. There's so many folks who, myself included, feel very lucky that we get to spend some time with you today. So thank you, Jess.
Thank you so much for having me. I really am. It was a really great privilege, and they were great questions. So I hope you guys tune in for the rest of the week. Thank you.
So friends, the fun unfortunately has ended today, but it's continuing throughout the rest of the week with our Women in Space Exploration talks. Please join us tomorrow as we're going to be working with Dr. Nadine Cox at NASA's JPL. She's a really incredible engineer working at spacecraft operations at JPL. So don't forget, tune in tomorrow at 9 a.m. Oh, excuse me, 10 a.m. Hawaii time. And it should be a blast. Thank you again to Pisces for hosting these really wonderful presentation series. We couldn't do it without our wonderful sponsors, including Microsoft and the Hawaii Space and Technology Museum. And folks, if we could ask for just a couple more minutes of your time, we would really love to get some feedback. So there's a QR screen or a link on your web page on your browser that you can use to just give us a little bit of information about our presentation and what we can do to make them better. So ahuiho, thank you again, Jess. Thank you to our sponsors in Pisces, and looking forward to seeing you guys tomorrow. Mahalo.